Deep in the mountains of California, where the air is cool and carries the faint sweetness of pine and cedar, there stands a tree. Not just any tree. A tree so large that standing at its base and looking up feels something like standing at the foot of a cathedral. A tree that has been alive since before many of the world's great empires rose and fell. A tree that holds more wood in its body than any other living thing on the surface of this earth. Welcome. I'm glad you're here. Whether you found your way to this video for the first time, or you've been resting with us for a while now, this is Sleepy Science, a place where we take the quiet, extraordinary wonders of our world and let them carry you gently into rest. Tonight, we're going to sit together beneath the oldest and largest living presence on the planet. We're going to breathe the cool mountain air of the Sierra Nevada. We're going to learn, quietly and slowly, about a tree that has been standing in the same spot for more than 2,000 years. There is no rush here. There is nowhere to be. All you need to do is let your body soften into wherever you're resting. Let your breath become slow and easy, and allow these words to be a kind of company as sleep finds its way to you. Let's begin. The tree is called General Sherman. It is a giant sequoia, the scientific name being Sequoia giganteum, and it lives in Sequoia National Park in California, in a grove known as the Giant Forest. By volume of living wood, it is the largest single organism on the planet. That word, volume, is important to understand. General Sherman is not the tallest tree in the world. That distinction belongs to a coastal redwood in Northern California. It is not the widest tree at its base, nor is it the oldest. But when you account for the sheer amount of living wood packed into its trunk and branches, no other single organism on Earth comes close. Its volume is estimated at just over 52,000 cubic feet. If you tried to picture that, imagine filling a large house with wood, then filling another house beside it, and still another beside that, and you might begin to approach the scale of what General Sherman holds within itself. The tree stands 274 feet tall. That is roughly the height of a 27-story building. Its base circumference measures nearly 102 feet. To walk in a slow circle around just the base of this tree would take you a minute or more. The largest branch on the tree is itself almost 7 feet in diameter, which means that single branch is wider than many fully grown trees of other species. And it weighs, by one scientific estimate, around 2.7 million pounds. 2.7 million pounds of living wood, of bark, of root, of the accumulated patience of more than 2,000 years. Take a breath with that for a moment. When we think about size, we often think about height or width as the thing that matters most. But there is something different and perhaps more moving about volume as a measure. Volume is fullness. It speaks to what something contains, rather than just how far it reaches. General Sherman is not merely tall. It is full, deep, dense with life. Every inch of it is occupied by the business of being alive of pulling water up from the earth, of turning sunlight into sugar, of breathing in carbon and breathing out the air that we depend on. It is, in the most complete sense of the word, alive. Now let us think about where this tree lives. The Sierra Nevada is a mountain range that runs along the eastern edge of California, stretching for about 400 miles. It is a place of dramatic contrasts. Dry foothills rise into dense forests of pine and fir, which rise further still into the high alpine zones where only rock and sky remain. The giant sequoias occupy a very particular band of this landscape, a narrow belt of elevation between roughly 5,000 and 7,000 feet above sea level, mostly on the western slopes of the range. This zone is specific enough to seem almost impossibly precise. Too low, and the conditions are too warm and dry. Too high, and the winters become too severe and the growing season too short. The giant sequoia's habitat is a band of maybe 2,000 feet of elevation, spread across a few dozen scattered groves. Of all the forests in the world, there is only this one narrow ribbon of mountain where these trees have chosen to exist. And within that band, certain groves hold trees that have been growing for millennia. The giant forest within Sequoia National Park is perhaps the most famous of these. It contains 5 of the 10 largest trees on Earth by volume, and General Sherman is the mightiest of them all. Picture the giant forest for a moment. You are walking on a trail of soft earth, packed smooth by decades of footsteps. The ground is carpeted in fallen needles, deep and reddish-brown, soft under your shoes. Above you, the canopy is high and broken, shafts of sunlight cutting through at angles. There is birdsong somewhere above, a woodpecker tapping in the distance, the faint rustle of a squirrel in the undergrowth. And then the trees appear. Not all at once. First you notice the trunks becoming wider. Then the bark begins to look different. Not grey or rough like a pine tree's, but reddish and fibrous, almost soft-looking, like the outside of a great rope. The trunks widen further still, and then you round a bend in the path. And there, in a clearing flooded with soft afternoon light, you see the base of something that cannot quite be processed at first. Your brain, used to measuring trees against houses or telephone poles, simply does not have a category for what you are seeing. The trunk is wider than the house you grew up in. The lowest branch is so high up it disappears into a green canopy that seems to belong to a different sky entirely. You take a few slow steps toward it, and the closer you get, the less of it you can see at once. You cannot take it in altogether. You can only stand at its side, feel the cool shadow it casts, and slowly become aware that you are in the presence of something ancient beyond imagining. That is General Sherman. Let us talk about the bark. Because the bark of a giant sequoia is one of the most remarkable things about it, and also one of the most underappreciated. The bark of General Sherman and trees like it can be up to 2 feet thick at the base. 2 feet. That is not the width of a plank, not the edge of a wall. That is a full arm's length of bark, soft and spongy and deeply furrowed, the color of cinnamon or rust or old copper. This bark is, in many ways, one of the tree's greatest secrets. It contains a chemical called tannin, the same compound found in tea and red wine. Tannin gives the bark a natural resistance to insects and fungi. Many trees are vulnerable to beetle infestations, to fungal rots that hollow out the wood. The giant sequoia, wrapped in this tannin-rich armor, is remarkably immune to these threats. But perhaps the most extraordinary property of the bark is its resistance to fire. The bark of a giant sequoia does not burn easily. It is thick enough and moisture-retaining enough that ordinary fires burning through the forest understory rarely penetrate to the living wood beneath. A fire may char the outside of the bark, leave black scars that persist for centuries. But the tree within continues living, continues growing, unaware almost of the flames that passed through. And here is where the story deepens, because fire is not the enemy of the giant sequoia. Fire is its partner. The giant sequoia has co-evolved with fire over millions of years. Its cones are sealed shut by a kind of resin that keeps the seeds inside through drought, through rain, through decades of waiting. But heat, the dry heat of a passing fire, melts that resin. The cones open, the seeds fall, and below them the fire has done something else. It has cleared the thick duff, that deep layer of old needles and debris, from the forest floor. It has opened the canopy to let sunlight reach the ground. It has left a thin layer of mineral-rich ash. And into this prepared seedbed, the tiny seeds of the giant sequoia fall, each one smaller than a rolled-up oat flake, each one carrying the possibility of a tree like General Sherman. This relationship between fire and forest is one of the most elegant examples of co-evolution in the natural world. The tree does not resist the fire. It waits for it. It depends on it. It has built its entire reproductive strategy around the inevitable return of flame. In the years when humans suppressed all fire in these forests, thinking they were protecting the trees, the giant sequoias struggled to reproduce. Without fire to open cones and clear the forest floor, seeds fell into conditions too shaded and too cluttered for seedlings to survive. It was only when scientists understood this relationship and began to allow carefully managed fires to burn through the groves again that the regeneration of the giant sequoia began to recover. There is something deeply quieting about that. The idea that what looked like destruction was always, in truth, preparation. That the charred trunks and smoking earth were not the end of something, but the careful tending of a beginning. That the tree knew this, in the way that trees know things, across millions of years of becoming. Let us think now about time. General Sherman is estimated to be between 2,100 and 2,700 years old. The exact age is not known. Unlike some trees that have been felled and had their rings counted, General Sherman still stands, and its rings cannot be counted from the outside. The estimate comes from comparisons with other sequoias, whose ages are known, and from the careful study of growth rates and core samples. But even the lower end of that estimate is almost impossible to hold in the mind. 2,100 years ago, the Roman Republic was still transforming into the Roman Empire. Julius Caesar had not yet crossed the Rubicon. The Library of Alexandria still held its great collection of ancient knowledge. The Silk Road was a new and tentative thing, just beginning to connect the great civilizations of East and West. General Sherman was already a tree. Not yet the vast organism it is today, but alive, rooted, growing in the same mountain grove where it still stands. Its first century of life was spent growing from a seedling no taller than a finger into something perhaps the size of a young oak. Slow and patient, pulling water from the snowmelt soil, turning thin mountain sunlight into growth, season after season. In the centuries that followed, empires rose and fell across the sea. The Roman Empire declined. The Dark Ages of Europe gave way to the medieval period. The great Gothic cathedrals were built and completed over the course of centuries. The Renaissance bloomed across Italy and beyond. Oceans were crossed. New continents were mapped. Revolutions shook governments from their foundations. Entire ways of life were invented and discarded. Through all of it, General Sherman stood in its grove. No earthquake toppled it. No flood uprooted it. No drought killed it. The snowpack of the Sierra Nevada covered it each winter and melted each spring, and the tree drank deeply and added another ring to its trunk and grew, almost imperceptibly, a little taller, a little wider, a little more itself. There is a quality to that continuity that feels almost like a comfort. In a world that seems always to be rushing, always changing, always arriving at some new crisis or discovery, the knowledge that this tree has been standing quietly in its forest for longer than recorded Western history is a kind of anchor. Something is still. Something is old. Something does not hurry. Now, you might wonder how a tree grows to this size. What does a giant sequoia eat? In a manner of speaking, what does it need? And where does it find those things? Like all trees, the giant sequoia survives on three fundamental things: sunlight, water, and carbon dioxide from the air. Through a process called photosynthesis, it takes these three ingredients and assembles them into glucose, a simple sugar, which the tree uses as its fuel for growth and repair. But to do this at the scale of General Sherman, the requirements are extraordinary. Water, for instance. A mature giant sequoia can absorb and use hundreds of gallons of water in a single day. In a hot summer, that number may rise even higher. The Sierra Nevada snowpack, which accumulates through winter and slowly melts through spring and early summer, is the primary source of this water. The roots of General Sherman spread wide and relatively shallow, more like a great raft under the earth than a taproot driving straight down. They extend outward in every direction, finding the moisture that seeps through the soil, drinking from the underground movement of snowmelt. And the carbon. This is one of the things that makes giant sequoias so important beyond their beauty and their age. Trees, as they grow, pull carbon dioxide from the atmosphere and lock it into the wood of their trunks and branches and roots. This process is called carbon sequestration, and it is one of the ways that forests help to regulate the chemistry of the air we breathe. General Sherman, with its extraordinary volume of wood, holds a correspondingly extraordinary amount of carbon. Estimates suggest it has locked away something in the region of 1,500 tons of carbon over the course of its lifetime. A single tree, holding that weight of carbon, so the sky does not have to. There is something deeply generous about that, even if the tree itself has no awareness of what it is doing. It breathes in what we breathe out. It holds what the atmosphere cannot carry. It gives back the oxygen that fills our lungs right now, in this quiet room, as you listen. This breath you are taking, part of it may carry the signature of a tree like General Sherman, of photosynthesis done 2,000 years ago and still rippling forward. Let that thought drift through you for a moment. The history of how General Sherman came to be named is a small and interesting story of its own. The giant sequoias of the Sierra Nevada were not widely known to the world outside California until the middle of the 19th century. To the indigenous peoples of the region, particularly the Monash and the Yokuts, these trees had always been part of the landscape, part of the rhythm of the mountains they called home. They harvested the fallen bark. They used certain parts of the tree. They lived in relationship with these forests for thousands of years, before any European explorer arrived to name them. When American settlers and surveyors arrived in the 1850s, they encountered these trees and were astonished. The largest specimens they saw seemed almost supernatural, a thing that large simply did not exist in the eastern forests they had grown up with. The first widely known discovery of a giant sequoia by settlers is often attributed to a man named Augustus Dowd, who reportedly encountered one of the trees while hunting in 1852. The account, perhaps embellished over retellings, claims that he ran back to the settlement and could barely describe what he had seen, that no one believed him until he led them to the tree themselves. The tree, now called General Sherman, was named in 1879. A naturalist named James Wolverton, who had served under Union General William Tecumseh Sherman during the American Civil War, came upon this particular tree while prospecting in the area. He was struck by its size and grandeur and named it in honor of his former commanding officer. It is a curious thing, the naming of trees, as if a thing that old and that large needed to be introduced to us, rather than the other way around. The tree existed for more than 2,000 years before anyone thought to give it a name in English. It did not need a name to be what it was. It did not need our recognition. It simply grew. And yet there is something understandable about the human impulse to name, to reach for language when confronted with something that exceeds all ordinary categories. When we cannot quite contain a thing in our minds, we give it a name as a kind of anchor, a way of pointing and saying, there, that, the thing that is too large and too old to be grasped, let us at least have a word for it. General Sherman. The name is both exactly right and somehow not quite enough. Let us drift a little deeper into the forest now. The giant forest in Sequoia National Park contains an estimated 8,000 mature giant sequoias. Not all of them are enormous. In relative terms, a sequoia with a base diameter of 10 feet would be considered almost modest in this grove. But even that modest by comparison tree might be 1,000 years old. 1,000 years old and carry a trunk that would require 6 or 7 adults stretching arms wide to encircle. To walk through the giant forest is to walk through time. The trees are spaced in a way that feels unhurried, not crowded together the way a plantation or a young forest might look. They have had centuries to establish their territories, to claim their patches of soil and light. Between the great columns of their trunks, ferns grow in the filtered shade. Young sequoia saplings, themselves perhaps 100 years old but still looking like ordinary-sized trees, reach upward trying to claim their place in the canopy. In winter, the snow settles on the branches in great soft mounds. The reddish-brown bark glows against the white. The grove is almost perfectly quiet, the snow muffling all sound. A raven calls somewhere far above. A branch releases its burden of snow in a soft cascade, and then the quiet returns. In summer, the sunlight moves through the canopy in slow patterns. The air smells of warm pine and the faint dustiness of dry soil. Mule deer pick their way through the undergrowth. Black bears, the color of soot, occasionally pass through, pausing to investigate something with their noses before moving on. Steller's jays, brilliant blue and black, move through the trees calling loudly. And above them all, the crowns of the great sequoias catch the last light of the afternoon and turn it a deep, warm gold. You might think that in such a place, it would be impossible to feel small. But it is exactly there that smallness arrives most clearly and most gently. Not an oppressive smallness, not the smallness of insignificance, but the smallness of a child standing beside something very old and very wise. A smallness that is, in its own way, a relief. You are small. The tree is vast, and that is entirely all right. Now let us think about the sequoia's neighbors. The giant sequoias do not grow alone. They share the forest with white fir, sugar pine, ponderosa pine, and incense cedar. These trees form the middle and lower stories of the forest, filling in the gaps between the great columns of sequoia trunks. The white fir, in particular, is something of a complicated neighbor. It is well adapted to shade, which means it can establish itself in the understory and grow without needing full sun. In forests where fire has been suppressed, white fir can crowd in so densely that it changes the character of the forest floor entirely, shading out the open patches that sequoia seedlings need to survive. It also acts as a ladder for wildfire, connecting the low flames of a ground fire to the upper canopy in ways that can be devastating. But the sugar pine, with its enormously long cones that can reach nearly 2 feet in length, is one of the most beautiful trees in the grove. Those cones hang at the tips of high branches like long ornaments, swaying gently in the wind. The incense cedar, with its soft, scale-like foliage and intoxicating resinous scent, fills the lower slopes. When its bark is crushed between the fingers, the scent is extraordinary, clean and sharp and ancient-smelling, like the inside of a very old chest. Animals move through this world at their own pace. The black bear is the largest mammal most visitors will encounter. They are patient, intelligent creatures, far more interested in acorns and insects and carrion than in people. In autumn, before hibernation, they enter a period called hyperphagia, an almost constant search for food, eating 20,000 calories or more a day. To build up the fat reserves they will live off through the long winter sleep. Coyotes pass through in the early mornings. Their calls at dusk, a rising and falling series of yips and howls, carry through the forest in a way that sounds ancient and somehow comforting if you are not the one being yipped at. The Douglas squirrel, also called the chickaree, is one of the few animals that actively harvests giant sequoia cones. This small, sharp-featured squirrel clips green cones from the branches and caches them or eats them. In doing so, it releases some of the seeds and inadvertently plants them. A small creature, performing a function essential to the largest living thing on Earth. This is how ecosystems work. Not in isolation, but in relationship. The vast and the tiny bound together, each depending on the other in ways that are not always obvious until you look very carefully. Shall we slow down even further now? Let your breathing settle just a little more. If you are lying down, feel the weight of your body against whatever is holding you. Let your shoulders drop. Let your hands be still. We're going to think about something very quiet. We are going to think about how a tree moves. You might not think of trees as moving things. They are rooted. They are fixed in place. They cannot walk or run or swim, and yet a tree is in constant movement. If you know how to look, water moves through the trunk of General Sherman in a process called transpiration. The roots absorb water from the soil. That water is pulled upward through the wood, through microscopic channels called xylem, all the way from the base of the tree to the topmost leaves, 274 feet above. The leaves release that water as vapor into the air, and the release of vapor creates a tiny suction, pulling more water upward from below. This process, called the cohesion-tension mechanism, is one of the most elegant physical processes in biology. Water climbing upward, against gravity, through the sheer pulling force of evaporation at the top. In a tree as tall as General Sherman, this is not a trivial feat. Moving water from the ground to a height of nearly 300 feet requires a tension in the water column that is extraordinary by any physical standard. The water is under a kind of negative pressure, pulled rather than pushed. It stays liquid under these conditions. Because of the strong cohesion between water molecules, their tendency to stick to one another, and to the walls of the tiny channels they move through. All day long, this silent flood of water rises through General Sherman, hundreds of gallons of it, moving upward in darkness inside the wood, carrying dissolved minerals and nutrients from the soil, supplying each leaf with the water it needs to do the work of photosynthesis. And meanwhile, in the other direction, sugar moves downward. The leaves make glucose, and that sugar is carried down through a different set of channels, called the phloem, to feed the living parts of the bark, the cambium, the growing regions near the base, the roots. Up and down, all day, all night, the tree rests a little, water movement slowing as transpiration drops. And at dawn, as the sun warms the canopy, the whole system comes alive again. The tree moves, quietly, invisibly, every hour of every day of every century. Let us talk about the cones. The cones of the giant sequoia are one of the great marvels of patience in the plant kingdom. Each cone is small by the standards of the forest. While the sugar pine produces those magnificent 2-foot cones, the sequoia cone is only about 2 to 3 inches long, roughly egg-shaped, brown and densely scaled. It looks, at first glance, almost unremarkable. But these cones can hang on the tree for 20 years without releasing their seeds. 20 years. While administrations change, while fashions come and go, while children are born and grow into adults, these small brown cones hang quietly on their branches, sealed, waiting, their seeds held in a state of readiness that can last decades. Each cone holds somewhere between 100 and 200 seeds, and each of those seeds is extraordinarily tiny. 1,000 seeds weigh only an ounce. A teaspoon would hold thousands of them, and from each of those seeds, given the right conditions, a tree like General Sherman could grow. But the odds are almost impossibly long. A sequoia seedling needs mineral soil exposed by fire. It needs sunlight, not shade. It needs consistent moisture through its first growing season. It needs to avoid being eaten by rodents or deer. It needs to survive the first winter, and then the second, and then many more. Most sequoia seeds do not germinate. Of those that do, most seedlings do not survive their first year. Of those that survive, most will not reach maturity. A giant sequoia grove is, in a sense, a monument to the small fraction of seeds that beat extraordinary odds. General Sherman itself began as a seed smaller than a flake of oatmeal. That seed fell to the forest floor, perhaps after a fire had cleared the ground. It landed in a patch of warm, mineral-rich soil. It received rain. The first root pushed down and the first shoot pushed up. And it began. Slowly. Patiently. 2,000 years ago. Now, let us think about what the tree has witnessed. Not witnessed in the way we do, with conscious awareness and memory, but in the sense that it has been present through an extraordinary span of events. When General Sherman was a young tree, perhaps in its first few centuries of growth, the indigenous peoples of the Sierra Nevada had already been living in and around these mountains for thousands of years. The Yokuts peoples occupied the foothills and the valleys to the west. The Monash, also called the Western Mono, lived higher in the mountains, following the seasons upward in summer and descending in autumn. These people moved through the giant forest. They knew the trees. They likely had names for the grandest of them, though those names were not written down in any way that has survived into the present. They gathered plants and bark fiber. They set fires intentionally to manage the landscape, to encourage the growth of useful plants, to keep the undergrowth clear. In doing so, they were partners with the ecology that the giant sequoias depended on. The fires they set were part of the same cycle of fire and regeneration that the trees had evolved alongside. The people and the forest were not separate things. They were the same system. General Sherman was several hundred years old by the time the first European explorers crossed the Pacific and began to approach the edges of North America. It was more than 1,000 years old by the time of the American Revolution. It was roughly 2,000 years old when the first American settlers arrived in California during the gold rush of the 1840s and 50s. In 1890, Sequoia National Park was established, becoming one of the first national parks in the United States, the second after Yellowstone. General Sherman was already ancient beyond reckoning. The park's establishment was, in part, a recognition that what grew here was irreplaceable, that no amount of commercial value could justify the destruction of something that had taken 2 millennia to become. And so, the trees were protected. Not perfectly, and not without conflict, but protected nonetheless. A circle was drawn around the grove. A boundary was set. And General Sherman has been growing, quietly, unhurriedly, within that boundary ever since. Let us rest here for a moment. Close your eyes if they are not already closed. Imagine the forest at night. The sky above the giant forest is very dark. On a clear night, far from any city, the stars are extraordinary. The Milky Way arches overhead in a dense, glowing band. The great trees stand in silhouette against it, their massive trunks like pillars holding up the sky. The temperature drops at this elevation. Even in summer, the nights are cool. The air carries the resinous scent of the trees more strongly in the dark. A great horned owl calls from somewhere deep in the forest, its low hoots carrying through the still air. An answer comes from farther off. Then silence. The moon, when it rises over the eastern ridge, casts long silver shadows through the grove. Each trunk throws a shadow 10 times its width. The ground, carpeted in needles, glows faintly. A deer moves at the edge of a clearing, pale and silent, then disappears. And General Sherman stands in its place, as it has stood through 10,000 such nights. Unhurried, unchanged in any way that a single night could reveal. The same tree it was yesterday, the same tree it was a century ago, growing so slowly that the change from one year to the next would fit on the thinnest sliver of a ring inside its trunk. There is something deeply restful about that. The idea of something that does not rush. Something that takes the long view, not as a philosophy or a practice, but as its very nature. The tree does not wake each morning and decide to be patient. Patience is simply what it is, what it has always been, what it will always be. Let that steadiness settle into you now. Breathe slowly. There is no hurry. There is nowhere to be. You are exactly where you need to be. Let us think about something delicate now. The seeds. We have spoken about how small they are, those tiny pale flakes carried by the cones. But let us follow one of them, in imagination, from the moment it leaves the tree. The cone has been hanging on a branch high above the forest floor. Perhaps it has been there for 10 years, perhaps 15. It has weathered winters and summers. Rain has fallen on it and dried. Snow has encased it and melted. Wind has moved the branch it hangs from, and it has moved with it a small patient passenger. Then a fire comes through the understory. The heat rises. The cone's resin melts. The scales open. And, from between the scales, dozens of seeds begin to fall. They are so light that they drift rather than fall. Each seed has a tiny wing, a papery flap that catches the air and spirals the seed gently downward. In a breeze, a seed might travel 100 feet from the parent tree. In a strong updraft from the fire, it might travel farther still. Below, the fire has done its work. The thick duff of needles has burned away. The mineral soil is exposed. It is warm. It is bare. It is open to the sky. Our seed lands there. It rests on the warm soil. The days pass. Rain comes. The seed absorbs water and swells. Inside the seed coat, something stirs. A root tip pushes outward, then a shoot. The seedling is no bigger than a blade of grass, impossibly small against the great trunks around it. But it is alive. It is pulling water from the soil. It is turning sunlight into sugar. It is beginning. Most seedlings like this one will not survive. A drought in their first summer, a late frost, a deer's casual nibble. But some will. And in the ones that survive, the future is incalculable. What will the world look like when today's seedling becomes what General Sherman is today? What languages will be spoken? What will the cities look like? Will there still be people who walk into this grove and stand beside the great trees and feel that particular combination of smallness and wonder? We cannot know. But the tree that is 2,000 years old today was once a seedling, smaller than your smallest finger, lying in the soil of the ancient forest. And against all odds, it kept going. There is something in that, worth carrying with you into sleep. The smallness that becomes the vastness. The beginning that cannot yet imagine its own ending. Now let us talk about something that often surprises people when they first learn it. The giant sequoia is not the oldest tree in the world. That might feel counterintuitive. Something so enormous, so ancient feeling, so clearly of a different time than everything around it, surely must also be the oldest. But the record for age belongs to another species entirely. The bristlecone pine. The bristlecone pine is a small, gnarled, almost tortured-looking tree that grows in the high, dry, wind-scoured mountains of the American West, where the giant sequoia is vast and stately. The bristlecone pine is twisted and ancient-looking beyond all proportion to its modest size. Some of these trees are over 4,000 years old. One specimen, known as Methuselah, is believed to be around 4,800 years old, making it one of the oldest known individual living organisms on Earth. Why can bristlecone pines live so much longer than giant sequoias? It comes down, in part, to the harshness of their environment. Bristlecone pines live where almost nothing else can. The soil is thin and poor. The winters are brutal. The growing season is so short that the trees add only the thinnest sliver of new growth each year. In such conditions, the wood is extraordinarily dense. Dense wood resists decay. Dense wood resists insects. And so the tree endures. In a paradox that the natural world seems to delight in, the harshest life produces the longest survival. The trees that grow slowest, in the most difficult conditions, where resources are scarcest and the stakes are highest, are the ones that outlast all the others. General Sherman, growing in the relatively rich conditions of the Sierra Nevada, with ample snowmelt and decent soil and a productive growing season, grows faster and larger. But the bristlecone, half dead by appearances, one side of its trunk bare and bleached by centuries of wind, the other side alive and productive in some impossibly narrow margin of viability, outlasts it by millennia. They are different answers to the same question. How do you persist? One answer: grow large and resistant, claim abundant resources, build thick armor. The other: grow slowly in harsh places, use almost nothing, endure. Both of them alive. Both of them ancient. Both of them, in their very different ways, extraordinary. There is something we should speak about now, which is the future. Not in an anxious way, not in a way that will trouble your rest, but because any honest conversation about the giant sequoia must acknowledge what is happening to the climate of the Sierra Nevada and what that might mean for trees like General Sherman. The giant sequoia's range is already narrow. It exists only in those specific groves on the western slopes of the Sierra Nevada. It requires winter snowpack to provide the slow, steady supply of meltwater that its roots depend on through the warm months. It requires fire, but fire of a particular character, the low-intensity ground fire that opens cones and clears duff, rather than the catastrophic crown fires that can kill even the largest trees. In recent years, some things have changed. Winters have brought less snow in some years. Drought has stressed the trees. Fires have become, in some cases, more severe than the trees evolved to withstand. In the Castle Fire of 2020 and the KNP Complex Fire of 2021, researchers estimated that thousands of large giant sequoias were killed by fires of unprecedented intensity, a loss that had not been seen in the historical record. This is not something to fall asleep in despair over, but it is worth holding gently. The trees are not invulnerable. The conditions that made them possible are not permanent. The relationship between the forest and the climate is one that needs attention and care. What is heartening is that people are paying that attention. Scientists are studying the groves carefully. Park managers are using controlled burns to reduce the fuel buildup that makes catastrophic fires more likely. Programs to replant sequoias in areas where fire has damaged the groves are underway. Seed banks hold the genetic material of the trees for safeguarding. The care being given to these forests is itself a kind of testimony, a recognition that what is here is worth protecting. That 2,000 years of growing deserves 2,000 more. General Sherman still stands. It has survived drought and flood and fire and the long centuries of human change. Its bark is scarred in places where fire touched it long ago. Its crown has lost branches to storms. But it is alive. It is drawing water upward. It is making sugar from light. It is adding, somewhere in the depths of its cambium, the thinnest new ring of wood. Growing. Still. Let us think now about the people who study these trees. The scientists and ecologists and botanists who spend their careers in the giant forest, learning the sequoias as one might learn a very old language. Some of them have been coming back to the same grove for decades. They know individual trees by their shapes, by the particular angle of a leaning trunk, by the scar left by a long-ago fire. They have measured the same trunks year after year, tracking the slow accumulation of growth. They have watched the cones through seasons of abundance and seasons of drought. There is a kind of intimacy in that kind of work that is not often associated with science. The image of science can feel cold and clinical, full of instruments and data and controlled conditions. But the people who study ancient trees develop something that looks a lot like affection for their subjects. How could you not? When you have spent 30 years returning to the same grove, watching the same trees through seasons and fires and droughts, there is a relationship there. One-sided, in the sense that the tree is unaware of you, but real nonetheless. Some researchers have described the feeling of entering a sequoia grove as arriving somewhere that feels meaningful in a way that is hard to explain. Not sacred in any specific religious sense, but carrying a weight of time and scale that recalibrates something in the mind. You arrive in a grove like the giant forest, and you are simply a different size than you were when you entered. Not physically, but in some internal sense of proportion. One scientist who spent decades studying giant sequoias described the experience of conducting fieldwork in the groves as being like working in a library that was also a cathedral. Quiet, ancient, full of things you are still learning to read. That image is a beautiful one. A library that is also a cathedral. Every ring inside the trunk a page. Every scar a chapter. Every year of growth a word in a story. Too long for any single reader to take in entirely. And yet the reading continues. Year after year. Patient person after patient person. The tree giving up its story slowly, in the way that very old stories are told, in pieces, across time, to whoever is willing to listen. Now let us think about what a tree ring tells us. Inside every tree, each year of growth leaves a record. In spring, when conditions are good, the tree grows rapidly and produces large, light-colored cells. In late summer and autumn, growth slows and the cells become smaller and denser and darker. Together, the light and dark bands form what we call a tree ring, one ring for each year. But the rings are not all the same width. A wide ring means a good year, plenty of rain, a long growing season, good warmth and light. The tree grew quickly and the ring is fat and clear. A narrow ring means a hard year. Drought, perhaps. A late snow that shortened a growing season. Stress from insects or fire. The ring is thin and tight, recording hardship in its very tissue. By reading the pattern of rings in a very old tree, scientists can reconstruct the climate of the past with surprising precision. A sequence of thin rings might correspond to a long drought, a series of wide rings to a period of unusual warmth and moisture. By comparing the ring patterns of many trees from the same region, scientists build a picture of climate extending back thousands of years, far beyond the era of written weather records. This science is called dendrochronology, from the Greek words for tree and time. It has allowed researchers to date old wooden structures in buildings and archaeological sites, to calibrate radiocarbon dating, to understand historical droughts that affected ancient civilizations. The giant sequoias, with their extraordinary longevity, are especially valuable archives. A ring record extending 2,000 years or more provides a window into a time before any instruments existed to measure the climate. The trees themselves became the instruments, recording in their wood what no thermometer was there to capture. So when you think about General Sherman, think of it not only as a living creature, but as a record, a document written in wood. Inside its trunk, hidden behind bark 2 feet thick, are 2,000 years of climate history. Good years and bad years, droughts and floods, the rhythms of El Niño and La Niña long before those names were coined, the slow pulse of the Pacific and the atmosphere, recorded faithfully, ring by ring, decade by decade. The tree is its own archive, and it is still being written. Let us slow our words even further now. The night is quiet. Perhaps you can feel your breath becoming heavier. Perhaps the weight of sleep is beginning to settle around you, like a soft and familiar thing. Let it. We will keep talking quietly, and you can let the words become a soft current, carrying you gently. We were thinking about the forest. Let us go back there for a moment. Imagine standing at the base of General Sherman in the early morning. The air is very still. The sun has not yet cleared the ridge to the east, and the grove is in a soft, grey, pre-dawn light. The bark of the tree is cool under your hand, not rough, but furrowed deeply, like the face of something ancient. The color of the bark is a deep reddish brown, almost terracotta, almost the color of old brick. You press your palm flat against it. The bark gives slightly, soft in a way you did not expect. It is spongy and fibrous, not the hard, rough bark of a pine. It absorbs your hand a little. It feels warm, even in the cool morning air, in the way that anything very old and very solid retains heat differently from lighter things. You look up. The trunk rises above you, narrowing very slowly, so slowly that the narrowing is barely perceptible for the first 100 feet. Then the first great branch appears, itself enormous, extending outward and upward. Above that, the crown spreads in the way that old sequoias do, broken and irregular, different from the perfect pyramidal shape of a young tree. Lightning has struck this tree. The top of the crown has been repeatedly snapped off by winter storms over the centuries. What remains is not a perfect point, but a broad, somewhat flattened mass of branches and foliage that catches the morning light and turns it green and gold. A bird lands somewhere up there. You cannot see it from below, but you hear it, a small, clear note in the silence, and then silence again. The sun comes over the ridge. A shaft of light cuts through the trees and falls across the base of General Sherman. The bark lights up, cinnamon and copper and deep red. The needles of the crown glow bright green against the blue sky above. A small drift of mist moves through the grove, catching the light for a moment, then fading. And the tree does not notice any of this. It does not notice the sun. It does not feel the light on its bark as pleasure. It does not see the mist. It simply is. Water is already moving up through its trunk. Photosynthesis has already begun in its needles. The business of being alive, conducted in absolute silence, without witness, without celebration. And yet we come here. We come from far away. We drive winding roads up into the mountains. We put on our walking shoes and make our way down the trail. And we stand at the base of this tree, and we feel something. What is that feeling? It is hard to name exactly. It is not precisely awe, though awe is part of it. It is not precisely reverence, though reverence is there too. It is something closer to recognition, perhaps. The recognition of something that exists on a different scale than everything you are used to, and the strange, unexpected comfort of that. The comfort of scale, of knowing that the world contains things larger and older and more enduring than any of your individual concerns, not in a way that diminishes those concerns, but in a way that gently repositions them. You are small, the tree says, without saying anything. But so is everything. And that is fine. That is, in fact, exactly right. Let us talk about the root system of the giant sequoia. It is both surprising and, when you understand it, deeply logical. Given the size of the tree above ground, you might expect a correspondingly deep and massive root system driving down into the earth. A taproot as thick as a person's torso, going down 20 or 30 feet or more. Something that could anchor 2 million pounds of wood against the pull of gravity. But that is not what the sequoia has. The roots of the giant sequoia are wide, not deep. They spread outward from the base of the tree in all directions, sometimes extending more than 150 feet from the trunk. But they rarely go deeper than 6 to 8 feet into the soil. Why? The Sierra Nevada soils, below the first few feet, become dense and rocky and poorly oxygenated. The roots that go deep find little to sustain them. The roots that spread wide find the shallow zone where snowmelt percolates through, where organic matter enriches the soil, where the oxygen that roots need is available. And so the tree makes a different bargain. Instead of a deep anchor, it creates a vast network. The roots of a single giant sequoia may share the soil with the roots of its neighbors, intertwining, sometimes fusing together in a phenomenon called root grafting. Multiple trees in a grove may be connected underground, their root systems joined, sharing resources in ways that scientists are still working to understand fully. The idea of trees sharing resources through their roots is something that has captured enormous public interest in recent years. Research has shown that in many forests, trees share sugars and water and even chemical signals through networks of soil fungi called mycorrhizae, a partnership so intimate and so ancient that the fungi and the trees have co-evolved to depend on each other. In a mycorrhizal relationship, the fungus wraps around the tree's root tips and extends outward into the soil in microscopic filaments called hyphae. These filaments reach into places the roots cannot, finding water and phosphorus and nitrogen and bringing them back to the tree. In return, the tree shares some of its sugar, the product of its photosynthesis, with the fungus. Together, they are more capable than either would be alone. The forest floor, beneath the soft carpet of needles, is threaded through with these fungal networks, connecting tree to tree, species to species, forming a web of exchange that reaches across the entire grove. The giant sequoias of the giant forest are not islands. They are nodes in a network, each one connected to its neighbors through root contact and through the invisible threads of the mycorrhizal web beneath their feet. When we look up at General Sherman and see a single tree, we are seeing something that is true, but not the whole truth. Below the surface, the forest is already one thing, already shared, already exchanging, already, in some sense, together. Now let us think about sound. What does the giant forest sound like? At different times of day and at different seasons, the answer changes. But there is a kind of baseline sound, a signature of the place that persists. The wind moves through the crowns of the sequoias with a different sound than it makes in other forests. The needles of the sequoia are very short, closely packed, and scale-like. When the wind comes through them, the sound is soft and high, almost like breathing. Not the roar of wind through pine branches, not the rattling of leaves, more of a sustained, gentle hiss, high above, barely there. In the understory, the sound changes. The large trunks deflect and absorb sound. The thick carpet of needles on the ground dampens footsteps. The grove has a quality of acoustic softness, as though the sound has been wrapped in something padded. Voices don't carry far. Even in a crowded grove, 20 feet away from another person, you can feel remarkably alone. There are the birds. The Steller's jay, a bold and beautiful bird in deep blue and black, calls loudly and often. The mountain chickadee, with its distinctive two-note call that sounds almost like a lazy whistle, moves through the lower branches. The white-headed woodpecker, a striking black and white bird, taps at the bark of a dead snag somewhere nearby. The red-breasted nuthatch spirals down tree trunks head first, making its small nasal calls. In late afternoon, when the wind tends to pick up slightly, the sound of the sequoia crown above becomes more pronounced. You can hear the branch movement, the occasional creak of wood. Sometimes a cone falls, hitting the branches below as it drops, landing with a soft thud in the needle carpet. And then, often, there is simply silence. Not absolute silence. There is always the wind, There is always something living somewhere nearby. But the silence of the forest is a full silence, a silence that has things in it. It is not the silence of an empty room, but the silence of a room where everything is perfectly at rest. That is the sound of the giant forest, at its quietest. And it sounds, perhaps, a little bit like this. We should talk about the other great trees of the grove. Because while General Sherman carries the title of the largest, it exists in extraordinary company. The giant forest contains 5 of the 10 largest trees on Earth by volume. Let us spend a moment with a few of them. The General Grant tree, located in the neighboring Kings Canyon National Park, is the second largest tree in the world by volume and is nicknamed the nation's Christmas tree, a designation given to it by President Calvin Coolidge in 1926. It is slightly shorter than General Sherman, but broader at the base, with a circumference close to 107 feet. It is also estimated to be slightly older, perhaps older than 1,500 to 2,000 years. The President tree, also in the giant forest, was studied using photographic imaging techniques that allowed scientists to map every branch and needle for the first time. The results were astonishing. The President tree, they found, had approximately 2 billion individual needles. 2 billion, each one doing the quiet work of photosynthesis, converting sunlight into sugar every hour of every day that the sun shines. Lincoln tree, Washington tree. The list of sequoias named after American presidents and historical figures goes on. There is something both touching and slightly amusing about this human instinct, to bestow the names of our most celebrated figures on trees that existed long before those figures were born, and that will, in all likelihood, outlast the memory of those names. In 1,000 years, will anyone remember why the Washington tree was so named? The tree will not know. The tree will simply be older, larger, still drawing water from the snow, still turning light into life. These trees outlast everything we give them, and perhaps that is fitting. Let us talk now about what happens at the very top of the tree. The crown of General Sherman, 274 feet above the forest floor, is a different world from the base. The wind moves freely up there. The sun arrives earlier in the morning and stays later in the evening. The temperature is different, sometimes cooler by day than the sheltered grove below, sometimes warmer on calm, sunny afternoons. Rain hits the crown directly, and the outermost needles are the first to feel drought when the dry season extends. The crown of a mature giant sequoia is irregular and ancient-looking. The perfect conical shape of a young tree has given way over centuries to something more individual. Lightning has struck. Winter storms have broken branches. New growth has filled in around the losses, in ways that are not symmetrical or predictable. Each ancient sequoia has its own crown, shaped by its particular history of storms and lightning and sun. And the crown is itself an ecosystem. Dozens of species of birds use the canopy of the giant forest. Some nest there. Some forage there. The cavities left by woodpeckers in dead branches become homes for owls and other cavity nesters. Insects make their lives in the bark and in the crevices of old wood. Lichens and mosses colonize the upper surfaces of branches where moisture collects. The very top of the crown of General Sherman has not been visited by a human being, very likely ever. It is an unreachable place. 274 feet of living wood stand between the ground and that topmost cluster of needles. What is up there, in that highest private world, we can only imagine. Perhaps the view. From that height, looking westward on a clear day, you would see the foothills falling away toward the Central Valley of California, the broad, flat agricultural plain that stretches for hundreds of miles. On the clearest days, when the air is free of haze, you might see the coast ranges in the far distance. To the east, the terrain rises steeply toward the peaks of the High Sierra, granite and ice, the rooftop of California. But the tree, of course, does not see any of this. It only reaches toward the light, steadily, upward, as it always has. Let us spend a few moments thinking about what it would feel like to be very small in the presence of the very large. There are accounts from visitors to Sequoia National Park, particularly first-time visitors, that describe a kind of emotional response to the trees that they did not fully anticipate. People who expected to feel impressed describe feeling instead something quieter, something more like stillness. One common experience people report is that the usual mental chatter quiets down. The lists and worries and replays of conversations that run constantly in most minds seem to fall silent in the presence of the great trees. Not because anything is solved or answered, but because the scale of what you are looking at puts everything in a kind of perspective that the normal scale of daily life cannot provide. Researchers who study the psychological effects of natural environments have identified what they call awe, a specific emotional state triggered by encounters with things that are vast and that require accommodation, meaning things so large or so powerful or so complex that our existing mental models cannot quite contain them. Awe does something interesting to the mind. It expands attention outward. It shifts focus from the self to the thing being witnessed. It produces a temporary quieting of the inner narrator, the part of the mind that is always commenting and evaluating. In studies, experiences of awe have been associated with increased generosity, reduced feelings of stress, and a sense that time is more spacious than usual. Standing at the base of General Sherman, this is what happens. The mind looks up. It cannot take in the whole tree at once. It tries to calculate the size and gives up. It reaches for context and finds none that quite fits. And in that moment of giving up, something relaxes, something lets go. The constant work of keeping track of everything is briefly, mercifully set aside. This is one of the gifts the tree offers. Not understanding, not answers, but a temporary release from the need for them, a moment of pure, wide, quiet attention. It is a small thing, in some sense, but it is not nothing. Perhaps now, as we move into the deeper and quieter part of this night, we can allow that release to happen here as well. There are no great trees in this room, most likely, but there is something of the forest here nonetheless. the knowledge of it, the image of it, the quiet certainty that somewhere in the mountains of California, in a grove of ancient trees, General Sherman is standing in the dark, and the cool and the silence, as it has stood for 2,000 years, as it will stand for many more. That continuity is a gift, even from here, even in this room, even as you close your eyes and let the day go. The tree is there, has been there, will be there. Still, quiet, holding the mountain to itself. Let that thought be a kind of anchor now, something to hold as you drift. The giant sequoia has one more quality we should speak about before we go much deeper: its relationship with snow. The Sierra Nevada receives some of the heaviest snowfall of any mountain range in North America. In a good winter, the snowpack can accumulate to extraordinary depths. Snow falls not in days or weeks, but in great continuous events. Storms that pile layer upon layer for days at a time. The giant sequoias, with their wide-spreading branches, intercept enormous quantities of snow. The branches bend under the weight. Sometimes a branch will drop suddenly, releasing its load with a whump that echoes through the quiet grove. Sometimes the weight of ice, accumulated over many storms, will break a branch entirely, leaving a pale scar on the trunk below. But the tree is designed for this. The wood of the giant sequoia is not the densest or hardest of woods. It is actually somewhat light and brittle compared to many commercial timbers. But its branches have a flexibility that allows them to shed snow loads before the breaking point is reached, most of the time. And the bark, thick and soft and fibrous, insulates the living wood from the freezing temperatures that accompany the deepest snows. Through the long winter, the grove is deeply buried. The lower branches of the trees hold dense masses of snow. The smaller understory trees are sometimes bent to the ground, but the great trunks of the sequoias stand clear and reddish above the white, unchanged in their fundamental nature by the season. Beneath the snow, the root systems are not frozen. The deep snowpack insulates the ground, keeping soil temperatures above freezing even when the air far above is bitterly cold. And within the wood of the trunk, very slow processes continue. Not the active transpiration of summer, but the quiet metabolic maintenance of life, the tiny trickle of activity that keeps the cambium alive and ready for spring. When the days lengthen and the temperature rises, the snowpack begins to melt. Not quickly. The Sierra snowpack is famous for melting slowly, releasing its water gradually through spring and early summer. This slow release is what makes the rivers and the forests of California possible. It is the snowpack, stored through winter and released through spring, that provides the sustained moisture that the giant sequoia's shallow roots drink so deeply from. And so the cycle turns. Snow falls. Snow melts. Water rises through the wood. Leaves make sugar. Cones mature. A ring is added, thin or wide depending on the year. And then snow falls again. Year after year. Century after century. 2,000 times and counting. Let us drift back to the grove one more time to close this part of our wandering. It is evening now, in the forest. The sun has gone below the ridge, and the light is fading from gold to grey. The air has cooled. The birds have mostly fallen silent. A single thrush still sings somewhere in the middle distance, its spiraling call moving through the trees in the growing dusk. The trunks of the great sequoias lose their colour in the fading light. They become dark columns, barely distinguishable from the shadow, only where a last sliver of sky is visible between the trees. Does the outline of the canopy remain, black against indigo? The air smells of cold stone and pine sap. The ground holds the faint warmth of the afternoon, releasing it slowly into the cooling air. A bat emerges from somewhere, its flight erratic and quick, hunting insects in the last of the light. General Sherman stands in the center of the grove, as it always stands, and the dark comes around it. No stars are visible yet through the canopy. The sky above is a deep, unclouded blue moving toward black. The first star appears at the zenith. Then another. Then the bright track of a satellite, moving steadily east. The forest settles into its nighttime self. This is not a silence of absence, but a silence of transition. The daytime creatures have gone to their roosts and dens. The nighttime creatures have not yet fully emerged. For a short time, the grove is between its two selves, and in that between time, it is simply still. Beautifully, deeply, anciently still. This is what the forest does every evening. This is what it has done every evening for thousands of years. And it will do it tomorrow evening too, without anyone to witness it, without anything needing to be done, simply because this is what evenings are. There is one more thing about giant sequoias that carries a particular kind of wonder with it, and that is the question of reproduction and succession. We know that the trees produce seeds in their cones. We know those seeds need fire and open mineral soil and sunlight to germinate. But here is the thing that makes you stop and think. A giant sequoia seedling grows very slowly in its first years. Very slowly. In the first 5 years of a sequoia's life, it may grow only an inch or two. By 10 years, it might be a foot tall. By 50 years, perhaps 15 or 20 feet. It would still look, at that age, like a reasonably ordinary young tree. Nothing to suggest what it will become. The first 100 years of a giant sequoia's life leave no outward sign of its extraordinary future. It does not look special. It does not grow faster than its neighbors. It competes for the same light and moisture as every other young tree in the grove. It is, by all appearances, just a tree. The transformation happens gradually, and by the time it becomes unmistakably itself, by the time the trunk has widened to something that makes people stop on a trail and stare, by the time the bark has taken on that deep reddish-brown character, by the time the crown has risen so high that you cannot see its top without craning your neck, centuries have passed. There is something about that speaks very quietly to the nature of deep, slow becoming. Things that will become extraordinary, often look ordinary for a very long time. The tree that will outlast empires, spends its first century looking like a small, unremarkable plant. It does not announce itself. It does not promise anything. It simply grows, ring by ring, year by year, towards something that cannot yet be seen. That patient becoming, that long and invisible transformation, is perhaps the most quietly beautiful thing about the giant sequoia. More beautiful even than its final size. The 2,000 years before it became the largest. The years of simply being. Of not yet knowing. Of growing anyway. Without hurry. Without knowing the end. Just growing. And now the night has deepened further. In the grove, the great horned owl calls from its roost high in a dead snag. One long, low hoot, and then another. The sound moves through the trees and is absorbed by the soft ground and the thick bark of the trunks. A coyote calls somewhere below the grove, on the edge of a meadow. The sound is distant and clear, the classic wavering call that seems to belong to another era. Then it stops, and the silence returns. The stars are fully out now. Through the gaps in the canopy, the Milky Way is visible, a band of dense light stretching across the opening above. A meteor passes, quick and silent, gone before you are sure you saw it. General Sherman stands in the dark. Its bark is cool in the night air. The water movement inside it has slowed but not stopped. The small metabolic fires of its life continue, barely perceptible, deep in the living layer between wood and bark. It does not sleep exactly, but it rests, as all living things rest, in their own way, through the dark. And here is a thought to carry you now into your own rest. You share this quality with the oldest tree on earth. The need for the dark. The need for the quiet. The slowing of the day's work. And the settling into something deeper and more still. Sleep is not the absence of life. It is life continuing differently. More inwardly. More quietly. Doing the work of repair and consolidation and memory that the busy daylight hours do not allow. Like the tree in the dark, you are not stopped. You are simply slower, restoring, becoming, in the night, what tomorrow will need you to be. Let us speak for a while about the sequoia's needle. Not the cone, not the bark, but the small, unremarkable, extraordinarily important needle. The needles of the giant sequoia are not the long, flexible needles of a pine. They are short, only 1/4 to 1/2 inch long, and they grow directly from the branch in a dense spiral pattern. They are stiff and slightly sharp-tipped, and they give the foliage a thick, bottle brush quality. From a distance, the crown of a giant sequoia looks almost like a mass of blue-green fur, dense and rounded at the tips of branches. These needles, billions of them on a tree like General Sherman, are the primary site of photosynthesis. Each one contains tiny structures called chloroplasts, packed with the green pigment chlorophyll, which absorbs red and blue light from the sun, and uses that energy to split water molecules, and combine their hydrogen with carbon dioxide from the air to make glucose. The oxygen that is left over, after the hydrogen is removed from the water, is released through tiny pores on the needle surface called stomata. These stomata are also how the tree breathes in carbon dioxide and breathes out water vapor during transpiration. They open and close in response to light and moisture conditions, regulated by guard cells that swell and shrink with water pressure. When conditions are dry, the stomata close to prevent water loss. When conditions are moist and the light is good, they open wide and the exchange of gases accelerates. The tree breathes more deeply, makes more sugar, grows more ring. Each individual needle on the tree lives for about 3 to 4 years before it is shed. This is a much longer needle lifespan than deciduous trees, which drop their leaves every autumn. By keeping its needles for multiple years, the sequoia avoids having to regrow all of its photosynthetic machinery from scratch each spring, saving enormous amounts of energy. The shed needles fall to the ground and form the thick, soft carpet that makes walking through a sequoia grove such a particular sensory experience. That carpet, building up over years and decades and centuries, eventually becomes the deep duff layer that both shelters the soil and, in its accumulation, creates the conditions that fire eventually clears. The needle is shed. The needle adds to the duff. The duff accumulates. The fire clears the duff. The cleared ground receives the next generation of seeds. The seeds become needles. The needles are shed, and the cycle moves forward again. In the sequoia grove, everything returns to everything. The needle becomes the ground. The ground becomes the seedbed. The seedbed becomes the tree. The tree becomes the needle. All of it moving in great slow circles, powered by nothing more than the sun and the snow and the quiet cooperation of living things. Let us think about what science has learned about the inside of a great tree in recent decades. For a long time, we thought of trees as relatively simple organisms. They make food. They absorb water. They grow rings. They provide habitat for other creatures. Useful and beautiful, but not complex in the way that an animal might be. But the picture has become more complicated and more interesting. Trees communicate, not in words or sounds, but in chemistry. When a tree is under attack by insects or other herbivores, it often releases chemical compounds into the air, volatile organic compounds that can be detected by neighboring trees. Those neighboring trees, upon detecting the chemical signal, may begin producing defensive chemicals of their own, increasing their tannin content or making their leaves or needles less palatable, before the insects have even reached them. This is not the same as the deliberate, conscious communication of language. The tree is not thinking, but the effect is strikingly similar. Information is transferred from one organism to another through a shared medium, and the receiver of that information changes its behavior in response. Below ground, the mycorrhizal networks we spoke about earlier also appear to play a role in resource sharing that goes beyond simple exchange between a tree and its fungal partner. Research has suggested that trees in some forests share sugars and other resources through the fungal network, sometimes in ways that appear to preferentially support younger or struggling trees. Older, established trees, with more photosynthetic capacity than they need, may contribute more to the network than they take from it. Some researchers have called this a wood wide web, a connected subterranean network of exchange, through which the forest distributes resources to where they are needed. The science is still developing, and the extent and nature of this sharing is a subject of active research and some debate. But the basic fact of mycorrhizal connection and the transfer of resources through it is well established. General Sherman, as one of the oldest and largest trees in the grove, is very likely a significant node in whatever network exists beneath the giant forest. Its root system, spreading more than 100 feet in every direction, touches and likely grafts with the roots of many of its neighbors. Its contribution to the mycorrhizal network, if the research holds, may be substantial. The largest tree, giving most. There is something right about that. Now let us think about measurement. How do you measure a tree you cannot fell? For decades, scientists used ground-level measurements to estimate the volume of standing trees. They measured the base circumference. They measured the trunk diameter at various heights using long poles and sighting devices. They used mathematical models of tapering to estimate how much wood lay inside the trunk between those measured points. But this method had significant limitations. The upper canopy of a giant sequoia is almost impossibly complex. Branches extend in all directions at different heights. Some branches are themselves as wide as medium-sized trees. The contribution of the upper crown to the total volume of the tree was very difficult to estimate from the ground. In recent years, new technology has changed this. Researchers have begun using a combination of ground-based laser scanning and aerial photography to build detailed three-dimensional models of individual giant sequoias. By firing thousands of laser pulses at the tree per second and measuring the time it takes each pulse to return, a scanner can map the surface of the tree with extraordinary precision, capturing every branch, every curve of the trunk, every significant protrusion in millimeter-level detail. The resulting models are breathtaking. You can see the whole tree from any angle, rotate it in space, zoom in on any branch. You can measure the volume of any section of the tree with accuracy that ground-level methods could never achieve. And what these models have revealed is that some earlier volume estimates may have been underestimates. The upper crown, in all its tangled complexity, contains more wood than the simple models predicted. The President tree, studied this way in a landmark research project, turned out to be even larger than its ground-based estimate suggested. Its total volume was revised upward. It is possible that further scanning of General Sherman might reveal similar surprises. The tree may be larger than we know, still holding secrets from us, even as it stands in a public park, visited by millions of people, still in the deepest parts of its canopy, offering more than we have yet been able to measure. Some things give up their full nature slowly. Some things, no matter how long we stand beside them, remain larger than our measuring. Let us think now about the visitor. The human visitor who comes to see General Sherman for the first time. They come from all over the world. From cities where the tallest things are glass towers. From flat farmland where the horizon seems to go forever. From other forests that have their own beauties, but not this particular grandeur. They park in the lot and follow the sign toward the General Sherman Tree Trail. The trail begins at an overlook and descends to the tree. This is deliberate. You see the crown first, from above, and then you walk down toward the base. The tree reveals itself gradually. The crown, then the upper trunk, then the middle, and finally, as you complete the descent, the base. At the base, there is a low fence that keeps visitors from compacting the soil around the roots. The fence is a modest thing, barely waist high. But it is important. The shallow root system of the sequoia is vulnerable to compaction, to the weight of millions of footsteps pressing the soil down and squeezing out the air pockets that roots need. Without the fence, decades of tourist visits might, paradoxically, harm the tree that people come to honor. Most visitors stand at the fence for a while. Some take photographs, though the tree is too large and too close for any single photograph to do justice to it. Some simply stand and look. Some press their palms against the bark of a smaller sequoia nearby. Children sometimes run around the base of the tree, trying to comprehend its size in the only way children can, with their bodies. Many visitors say very little. This is a consistent observation from rangers and naturalists who have worked in the grove. The great tree seems to produce in its visitors a kind of willing quiet. People who arrived chattering find themselves slowing down and falling silent without being asked. The scale of the thing draws the voice inward. Language, which is usually so adequate for describing experience, seems suddenly thin. What do you say about something like this? There are no words in any human language that were specifically made for this experience. We reach for the ones we have. Massive, ancient, incredible, unbelievable. But none of them carry the full weight of the thing. None of them do justice to 2,000 years of quiet becoming. And so, wisely, many visitors simply stop talking. They look. They breathe. They are present in the fullest sense of the word. And then, slowly, they begin the walk back up the trail, back to the parking lot, back to the car, back to the rest of their lives, carrying something with them that is hard to name, but will not leave them for a long time, perhaps ever. There is a quality of old forests that deserves a name it does not yet have in English. The Japanese have a word, Shinrin-yoku, which translates roughly as forest bathing. It refers to the practice of spending time in the forest in a slow and intentional way, not hiking for exercise or navigating to a destination, but simply being in the presence of the trees, breathing the air, listening to the sounds, allowing the scale and the age of the place to do something to the nervous system. Research has found that time spent in forests has measurable effects on the body. Blood pressure tends to decrease. Heart rate slows. Cortisol, a marker of stress, drops in the blood. Immune function shows markers of improvement. Mood lifts. Attention restores. Some researchers attribute this to the chemical environment of the forest. Trees release compounds called phytoncides, which are part of their chemical defense systems, the same volatile organics that allow chemical communication between trees. When we breathe forest air, we inhale these compounds. Some evidence suggests they interact with our own immune cells, stimulating a type of white blood cell that plays a role in fighting infection and abnormal cells. The forest heals in its quiet way, not in the dramatic sense of medicine, but in the slow and consistent sense of restoration. The way sleep heals, the way a long breath heals. Small corrections, applied steadily over the course of a slow and unhurried hour in the trees. And the older the forest, the more of this the air seems to carry. The giant sequoia grove is one of the oldest forests in the world. Its phytoncide environment, its acoustic softness, its quality of light and scale, are all the product of thousands of years of uninterrupted growth. You cannot replicate that in a young forest. You cannot replicate it in a park or a garden. It takes centuries. It takes the particular compound of age and biodiversity and undisturbed succession that only an ancient forest can accumulate. This is another reason why what exists in the giant forest is irreplaceable. Not merely as a spectacle, not merely as a cultural treasure, but as a living pharmacopoeia, a place that does something specific and measurable and valuable to the physiology of human beings, simply by being what it is. The forest heals, and we are part of the system it heals. We are always, even when we forget it, part of the same system. One more thought before we begin to let go entirely. Scientists who study the giant sequoias have noted something that they sometimes call the illusion of permanence. When you stand at the base of General Sherman, the tree feels permanent. It feels like something that has always been there and will always be there. Its scale makes it seem geological, as permanent as a mountain. But it is not a mountain. It is alive. And things that are alive are, by definition, temporary. General Sherman will die someday. No one knows when. It might be 1,000 years from now. It might be sooner, if the conditions of its survival change in significant ways. It might die slowly, declining over decades as the top of its crown dies back and fewer of its needles can sustain the whole. It might fall in a windstorm. It might be killed by a fire of unusual intensity. The specific manner of its ending is not known. But the grove will continue. Even if General Sherman falls, there are 8,000 other mature giant sequoias in the giant forest alone. There are young sequoias growing in the groves where fires have opened the canopy in recent years. There are seeds in storage. There are people committed to studying and protecting this species. The tree as an individual will end. The sequoia as a living legacy will not. And perhaps that is the final, deepest comfort of this place. That the individual is not the whole story. That the single tree, magnificent as it is part of something larger than itself. part of a grove, which is part of a forest, which is part of a mountain range, which is part of a continent, which is part of a world that has been making and remaking its forests for hundreds of millions of years. General Sherman is one note in a very long song. But what a note! There is one final thing we should hold before sleep fully comes. And that is the simple fact that you have spent this time here. In the midst of whatever this day held, whatever was busy or heavy or loud, you found your way to a quiet corner of the evening, and you let yourself rest with an old tree for a while. That is not a small thing. The world is very good at filling every moment with urgency, with the sense that there is always something to do, always something to fix, always something that needs attention right now. The space to simply be quiet, to let the mind settle, to rest in the company of something ancient and unhurried. That space is rarer and more valuable than it might seem. The giant sequoia does not know you are thinking about it tonight. It does not know it has been your company through this quiet hour. It stands in its grove, as it always stands, without awareness of the miles between you, without any sense of the exchange that has happened here. But you know, and the knowing of it is its own kind of gift. To have spent time with something 2,000 years old, to have let its patience be, for a little while, your patience, to have let its stillness be your stillness, its rootedness be your rootedness, its slow and ancient breathing, a rhythm your own breath leaned toward. You have been, in some small and quiet way, in the presence of the oldest. And you carry that with you now, into the dark, into the deepening quiet, into the rest that your body has been waiting for, all day long. Somewhere in the Sierra Nevada, at an elevation of about 6,000 feet, on the western slope of a mountain range that has been here for millions of years, a tree is standing in the dark. Its roots are touching the roots of its neighbors. Its bark is cool and quiet in the mountain air. Its needles, 2 billion of them or more, are resting in the darkness, waiting for the return of the light. Its rings, more than 2,000 of them, are held inside the wood, a quiet record of every year the world has turned, since the tree was a seedling in the ancient soil. It does not wait for morning with any anxiety. It does not worry about whether morning will come. It simply rests in what the night is, knowing, in whatever way a tree knows anything, that the sun will return, that the snow will melt, that the water will rise through its long trunk again, that another ring will be added, quietly, invisibly, in the dark beneath the bark, as it has always been added. Now let us think about the seasons of the sequoia grove, one by one, as they move through the giant forest. Spring comes late to this elevation. While the valleys of California are already warm and green in March, the giant forest still lies under snow well into April and sometimes May. The sequoias stand in their white world, with a patience that is almost indistinguishable from indifference. But inside the bark, something is already stirring. The lengthening days trigger changes in the cambium, the cells that have been dormant through the cold months, begin to divide again. The first new xylem cells of the year are laid down, large and pale, the beginning of the new ring. And as the snowpack begins to release its water into the soil, the root hairs absorb it eagerly, and the long upward journey of water through the trunk begins again. The first green things appear below the trees. Shooting stars, a small wildflower with swept-back petals the color of deep pink, push up through the patches of snow. Corn lilies emerge in the wet meadow edges. The first bumblebees, newly emerged from winter dormancy, move slowly through the cold air, searching for anything in bloom. The birds return. Warblers arrive in the understory, small and quick, their songs filling the grove with a brightness that was absent all winter. The hermit thrush begins its liquid, spiraling song in the evenings, one of the most beautiful sounds in any American forest. And overhead, the ravens that stayed through the winter perform their aerial displays, tumbling and rolling in pairs against the pale spring sky. Summer arrives fully and warmly. The days are long and the light is strong. The sequoias are in their season of maximum photosynthesis. Hundreds of gallons of water move upward through each trunk each day. The new ring is growing. The cones are ripening slowly on the branches. The meadows fill with wildflowers in succession, each species taking its turn in the sun, blooming and seeding and fading as the season moves forward. Thunderstorms build in the afternoons over the high peaks. Lightning sometimes strikes the sequoias. A direct strike can shatter a branch or scar the bark. Over many centuries, repeated lightning strikes can hollow out sections of a large trunk. General Sherman carries the scars of many such strikes in its crown, each one a chapter of its long history with electricity. In autumn, the days shorten and cool. The deciduous plants in the understory begin to change color. The ferns turn gold. The deer maple and the dogwood bring splashes of red and orange to the slopes. The black bears intensify their search for food, moving through the grove in the low slant of autumn light, eating constantly, preparing for the long sleep ahead. The sequoias do not change color. Their needles remain the same deep blue-green through all 4 seasons. While everything around them cycles through its annual drama of greening and reddening and dying back, the great trunks stand unchanged, their color constant, their presence unaltered. They are the anchor the eye returns to, the thing that persists while everything else transforms. And then winter comes again. The first snowflakes fall. They settle on the needles in the crown first, then on the branches, then begin to accumulate on the ground. The birds go quiet. The bears disappear into their dens. The meadows vanish under white. And the grove grows still. And General Sherman, as it has done for 2,000 winters, stands in the snow and waits for spring. Patient, as always. Patient as only something that ancient can be. Let us think now about one more dimension of the tree that we have not yet fully explored. Its relationship with death. Not its own death, not yet, but the death that happens within it and around it. Dead wood is not the absence of life. In the ecology of an old-growth forest, dead wood is some of the most alive material in the ecosystem. When a branch dies and falls from a giant sequoia, it does not simply decompose and disappear. It becomes a world. Fungi move in first, their mycelium threading through the dead wood, breaking down the cellulose and lignin that make up the structure. They soften the wood, making it accessible to the next wave of colonizers. Beetles arrive, their larvae boring through the wood in long tunnels, feeding, growing, pupating. Woodpeckers follow, hammering into the soft wood to reach those larvae. Their excavations leave cavities, and those cavities are taken over by owls, by small mammals, by other birds. The fallen log becomes a nurse log. Mosses and ferns establish on its surface. Sequoia seedlings sometimes germinate in the crumbling wood of old logs, finding in the rotting wood a combination of moisture and nutrients that the dense forest floor cannot always provide. Over decades, the log softens and crumbles. It merges with the soil. The nutrients it contained, the carbon it locked up during its years of photosynthesis, are released back into the ecosystem. They become soil. They become available to the roots of the living trees. They become, eventually, the next generation of needles and wood and bark. Nothing is lost. Everything returns. The dead branch becomes soil. The soil becomes root. The root becomes trunk. The trunk becomes branch. The branch falls and becomes soil again. Around and around. Across centuries, the atoms themselves cycling through living form after living form, never created and never destroyed, only moving, always moving, from one expression of life into the next. The carbon that is now in the wood of General Sherman was once in the air. Before that, perhaps in the ocean. Before that, perhaps in the body of something that lived before the Sierra Nevada existed as a mountain range. And after General Sherman is gone, that carbon will continue. Into the air again. Into the soil. Into the next tree that grows in the grove. Into whatever comes after. The tree is not a destination. It is a waypoint. A temporary, magnificent, 2,000-year-long waypoint in the endless circulation of matter through life. And in that, it is exactly like everything else, including you, including this breath you are taking right now, including this moment. Let us settle now into the very last quiet. Your breath is easy. The forest is far away and also very close, in the way that things we have thought about become part of us. The giant sequoia does not know it is the largest. It does not carry the weight of its own superlative. It simply grows toward light, drinking water, making sugar, holding on. And perhaps that is the most honest and most restful thing of all, to simply be what you are, in the place where you are, without needing to be larger or older or more remarkable than you already are. The tree does not strive to be the largest. It simply grew into it, over 2,000 years, one ring at a time, without rush, without awareness, without any sense of destination. It simply was. and in the being, it became. Let that be your thought now as sleep comes for you. Simply be here, in this bed, in this breath, in this quiet, and trust that the becoming will take care of itself, as it always has, as it always will. Just as the ring is added in the dark, just as the water rises without being asked to rise, just as the cone waits without knowing what it is waiting for, you can rest now, without needing to know what comes next, without needing to hold anything together, without needing to be anything other than this: alive, breathing, here. The forest holds you in its thought, if such a thing can be said of a forest. The 2,000 years of the tree steady somewhere in the back of the mind, an anchor in all this turning. Sleep now. Let that be the last image you carry into sleep. The largest living thing on earth, resting in its forest, steady and old and unbothered by the dark, standing in the same place it has stood for 2,000 years, adding its slow ring, patient as stone, alive as anything has ever been alive, quiet. And you, here, breathing slowly, letting the day go, letting the night come, as nights always come, gentle and dark and full of rest. You are exactly where you are supposed to be. Everything is all right. Everything is still. Sleep now. The tree will be there in the morning. It will still be adding its slow ring, still drinking the snowmelt, still reaching toward the light, still the largest, still patient, still there, as it always has been, as it always will be, still. Good night, and thank you for resting here with us on the Sleepy Science channel.